Hi guys, I wanted to go through this mole conversion roadmap that's in your book on page 303 and try and help you. This is definitely not the easiest topic, and so if you're having troubles with it, you're in good company. Let's just go through a few basic things. Just a friendly reminder, moles are the heart of chemistry. Ha ha ha. And everything has to go through moles. It's just a way of counting. Remember, it's just how we get the number of things. And when reactions happen, there's a count that has to happen. Particles have to be matched up in the right proportions. A couple other things I wanted to just remind you. When you're doing conversions, make sure that the conversion factor has the units of the asked for, what you're trying to solve for, the units of that in the numerator and the units of the given information in the denominator. So asked for over given is the way to save yourself. I will tell you that I get myself confuddled just as easily as you do, and I've been doing this for a lot longer, and by having those units in my conversion factor, I can find out right away if I'm doing the wrong math operation. Another little thing that I want to remind you of when we're talking about gases, that little bit of information that you've already read about, STP, standard temperature and pressure, 0 degrees Celsius, 1 atmosphere of pressure. That's really cold. That's not normal lab conditions, but that's what we work with. And so there's two conversion factors when you're dealing with gases. 22.4 liters per 1 mole can also be written as 1 mole per 22.4 liters. So this is an equivalency. Just like 1 foot is 12 inches, 1 foot is 12 inches. Doesn't matter. It just depends on which way you're trying to convert. What you're starting with should be on the bottom. What you're trying to end up with should be in the numerator. Okay. A couple other things just to point out real quick. Of course, there's all different things that we have to calculate in chemistry. The very first one they started out with was representative particles. And remember, you have to be a little bit cautious with this. This could be, so they'll put RPs, representative particles. They could be atoms, they could be molecules, they could be ions, they could be formula units for ionic compounds. The one that you need to really watch out for are those elements that are diatomic. So they're really existing in molecules, even though you might think they're atoms. Okay, so watch out for that. All right, so those are pretty straightforward. You'll notice that this is a two-way street. We can go from particles to moles. Notice we're dividing by 6.02 times 10 to the 23rd. We can also go from moles into particles, and this time we multiply. So the going into the moles part is a division process, multiplying by 1 over the inverse, and doing the moles to something process is a multiplication process, and that's going to be really important. Some of you will catch it right away. Others of you, like me, are going to have to put the units down to make sure you're doing the right thing. The next thing they talked about in the book was about mass. This is honestly, for most of our work, is going to be the most important way to convert. When you're dealing with gases, this is very helpful as well, but we still end up using mass too, so it gets a little complicated. But mass, of course, is measured in grams, so even if they don't ask you specifically for mass, if they say they want to know the number of grams, it's mass. And this is where you have to remember about molar mass. So that's the problem within most of the problems. You have to find the molar mass of the compound before you can do the conversion from mass to moles or moles to mass. Again, when you're going into moles, you're dividing by the molar mass, multiplying by 1 over the molar mass. When you're coming out of moles into mass, you're multiplying. All right, and then the last thing that you had to learn about was volumes of gases. I already talked about STP, that's over here. Same idea. If you're going from a volume, which of course is in liters, you guys know that, from a volume into moles, you're going to divide by the molar mass, by 22.4 liters. And when you're going from moles to volume, you're going to multiply. Okay, so how does that look for your problem solving? Well, let's go through it real quick. Again, got to go through moles to get from one side to the other. So I could go from particles to grams. I could go from volume to volume. I could go from mass to volume. There's all different ways we can convert things, okay? So in this one, if we want to go from mass to moles, that means we're starting with a number of grams. I need a conversion factor that has moles on top, grams on the bottom. And that particular one would be the molar mass. Okay, if I want to go from volume, that's in liters, to moles, again, I'm going to put moles on top because that's what I want. And I'm going to put 22.4 liters. Of course, this is always assuming an STP. Just a little caveat. Okay. If I want to go from particles to moles, so I'm going to go number of RPs. I'm going to, again, my conversion factor is going to have 1 moles on top, and our friend 6.02 times 10 to the 23rd RPs, whatever they are, atoms, molecules, ions, formula units, on the bottom. So again, you can imagine the starting thing is over 1. So what you start with is in the numerator. Grams on top, cancel grams on bottom, you're left with moles. Liters on top, cancel liters on bottom, you're left with moles. Represented in particles, cancel, you're left with moles. Okay, so all of these processes involves division. Okay, to go from something into moles, you're dividing. Okay, all right, well, what if you have a number of moles to start with? Well, this time, they're all going to look really similar. Number of moles, number of moles, number of moles. But this time, I'm going to put per mole, per 1 mole, the molar mass in grams in the numerator. In this one, I'm going to put 22.4 liters per 1 mole. And in this one, I'm going to put 6.02 times 10 to the 23rd RPs per 1 mole. Again, you can imagine this over 1. Moles on top, cancel moles on the bottom. You're left with grams. Moles on top, cancel moles on the bottom. You're left with liters in your answer. Moles on top, moles on the bottom. You're left with whatever particles you're supposed to have. And so all of this conversion from moles to mass involves multiplying. From moles to volume, multiplying. From moles to particles, multiplying. And all of those then can work together. Okay, so hopefully that is helpful, and I'll do the next part on another video. Take good care.